All right, guys, so we're going to take a look at some more examples. Again, you should have graph paper or you can actually snip. If you have a Chromebook, you can go ahead and say snip for Chromebook. It enables you to do what I'm doing on the right-hand side. So again, here are the instructions. It looks like you just need to press the screenshot key, which is this key right here. If your Chromebook doesn't have that, you press Shift, Control, and Show Windows. So Shift, Control, and Show Windows. Okay. These three keys will screenshot what you have, which will enable you to basically have this, because that's what I did. I screenshotted this here. So once you have it screenshot or you have graph paper, okay, one of the two things, you can go ahead and get started, at least until you get good. So let's go ahead and do this first equation right here. So we're going to graph 2x plus 5. So once again, the plus 5 represents your y-intercept. So plus 5 is your y-intercept. So on your graph paper or on your screenshot, you're going to go to 5 and draw a graph, a point, sorry. Then the slope is the number before the x right here. And remember, you want slope to be rise over run. So what does that mean? I need this to be 2, and I need it to be over something. So what can I do in order not to change the number 2? I can put an invisible 1. 2 divided by 1 is still equal to 2. So this is my rise, and this is my run. So I'm going to rise positive 2, and I'm going to run positive 1. So I'm going to rise 1, 2, and run 1, and put a point. Then you can take your composition book or your credit card or a straight edge, anything that has something straight, and connect the dots. And what that does is it'll connect it accurately. But since I'm drawing freelance, I'm actually going to count to make sure it's fine. So this is 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, and that probably should be enough. Okay, so again, you're using a straight edge so that your line can be accurate. Okay, once you have that, we're then going to work on our restrictions. Okay, so what is this telling me? X exists between -3 and 0. So I'm going to go to the x-axis right here, between -3, which is right here, and 0, which is right here. So I only want this piece of the graph in this pink place. So now I'm going to transfer this graph, only the one that's inside the pink, into my actual answer. So I need the -3, which was -3, -1. And this is why you have to be really accurate. As well as you can see that I did have these dots going here so that you can actually do the pattern as well. So, you know, down to right, left 1, down to left 1, down to left 1, down to left 1. So you can see that -3 is -1. All right, and then my other point right here is 0, 5. So -3, -3, 1, -1. So -3, -1, and then you're going to just drag it. See, once you drag it, it starts dragging 0, 5. So that's just this part of the graph. Once you have this part of the graph, now you're looking at what is my restrictions, okay? What is happening at the ends? So this is the left-hand side. What's happening there? This is a closed circle. Is it closed already? It is. What's happening on the right-hand side? So looking at the right-hand side, is it open or closed? It is open. So open. So once again, this is a closed, and this is open, okay? And then this goes on forever on both sides of your graph. If it didn't have this restriction, then you might have to put an arrow, but we'll get to those examples in just a little bit. All right, so I've graphed the first one. Then on a different graph paper, so what you're going to see me do is I'm just going to delete this so that you don't get confused. A different graph paper, we're going to do this second one. All right, so the second one, again, starting just like we did before, you start with the y-intercept, which is +4. Boom. And then what does this tell me to do? So I'm going to do it over here again, rise over run. And the number I have is negative, right? So if I have an apple, how many apples do I have? I have 1 apple. So if I have an X, I also have 1 X. So I can put 1. And because there's nothing on the run, I can also go ahead and put 1. So -1 divided by 1. Okay, that is still -1. So rise is going to be down because it's a -1, and run is going to be right 1. All right, so I'm going to go down 1, right 1, 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 down 1, right 1. And again, you just take a straight edge. So your composition book hardcover is straight. I'm just going to kind of wing it. All right, but you notice I just keep doing down 1, because I'm not very straight freelancing. So I have these points in case I need them. All right, now that I have my graph drawn, so it goes on forever in both directions, this is my restriction. So what does it say? X lies between 0 and 6. So I go X between 0 right here and 6 right here. So I draw my little domain restriction. All I care about is what's in here. So let me transfer this into my actual graph. So this point right here is 0, 4, and I want the point at 6, which is 6, -2. So 0, 4, and I'm going to put my pen down, then drag it. 6, -2. Boom. Okay, so I've transferred just this yellow piece right here into my actual answer. All right, let's talk about the endpoints. What do the endpoints look like? So looking right here, it is open. So we're going to go to this endpoint and open it. And then looking right here, it's also open. So we're going to go to this endpoint and open it. All right, that's how you draw piecewise functions. So it's two graphs at the same time. Okay. All right, we're going to go ahead and do another example. So I just did something similar to that. So I just want to kind of pick different problems. So here's a different one. All right, so again, on a fresh sheet of graph paper, you can just do one graph per paper, or you can take a screenshot on the Chromebook with how I discussed with you how to do that. Once you have your screenshot, you can just put it on the side and you can use your mouse to sketch it. All right, so let's go ahead and draw the first one. So this is actually a great example because again, what's my y-intercept? -16. But does this graph go to -16? It does not. So this is a special situation. When you get into that situation, what you're going to do is you're going to make an X and Y table. Now, you can pick 1,000 points, and instead of choosing 1,000 points, I'm going to show you what you're going to do. So we're going to look at our domain, and our domain says that I'm only interested in numbers that are less than or equal to -5. So I'm going to start off actually with -5 because I care about -5. And then just pick any number that's less than -5. What I like to do is if I'm picking, so here's -5 right here, right? The number is less than -5 on this side. So I'm going to pick this last one so that I can have two dots to join, okay? Sometimes this last one is off the graph. And if that's the case, pick a number closer to -5. All right, but for this case, I'm going to pick -10. And again, these numbers, you're making them up. So it's anything less than -5, any number less than -5. And what you're going to do is you're going to plug that in. So anywhere I see an X, I'm going to put -5 in the place. So you started off with -2, then I see X, which is -5 minus 16. Okay, so then you just stick that in a calculator. So I have, that's going to be +10 minus 16 is going to be -6. But you can just use a calculator. Then I have -10 in here. So I have -2. And instead of X, I'm going to put -10 minus 16. -2 times -10 is going to be +20 minus 16 is going to be 4. So now I have my 2 points because both of those are on the graph. So remember, if this point is not on the graph, just pick a point closer to this number, the first number you picked. So let me go ahead and plot those points. So -5, -6. So -5, -6, that's a point. And -10, 4, -10, 4. All right, again, use a straight edge. The composition book has a straight edge, a credit card, debit card, ID, something like that. All right, so this is my graph, but I'm only interested in this graph between the points where X is less than -5. So here's X, -5. So I'm only interested here to the left, right? This point right here. So I'm going to transfer this part of the graph here. All right, so let's go ahead and transfer it. So we have -5, -6, and then this point right here is -10, 4. -5, -6, and then -10 and +4. Now, if you look right here, what can you tell me? That graph goes on forever, right? It's just that I don't have enough graph paper. So what we do is we represent that by clicking it twice to make it an arrow. That signifies it goes on forever. All right, what about this point right here? Do we include it or don't we? So let's look at what it says here. It does not have the equal underneath it, so this is an open. So let's make it open. All right. Again, refresh your screen, or you can, if you're doing this on graph paper, just do a new graph so it doesn't get confusing. I'm just going to erase it. All right. And then I'm going to do the second one. So what does this mean? Y is equal to 5. Y is always equal to 5 no matter what X is. So whatever I say X is, Y is equal to 5. So let's go ahead and plot this. X is -10. What's Y? 5. X is -3. What's Y? 5. Doesn't matter. Y is always equal to 5. X is 3. What's y? 5. X is 10. What's y? 5. X is 7. What's y? 5. And you can see that that makes a horizontal line at y equals 5. Okay, so y is always equal to 5. Okay, what's my domain restriction? I'm looking for anything bigger than the number 5. So x is bigger than 5. So x, then you find 5. So here's my restriction right here. All right, now we're transferring this to the graph. So I'm going to go to 5, 5, and draw a horizontal line. So 5, 5, and draw a horizontal line. All right, let's talk about endpoints. Let's start with this right here. What do I see over here? I see an arrow, right? Because it keeps going that way. So you're going to click it once, twice. Make sure you have your arrow. Okay, and then what about this point here? Do I include it? Let's take a look. So what do I have here? Is it open or closed? Open. So I make this open. And that's how you do these problems. All right, let's do another one. I think that one's kind of similar. That one's kind of similar. Is there one that's kind of mixed? Let's do it. Shall we do another one of these? Let me. Oh, let's do it. This looks complicated. Okay, let's do this one. All right, so again, you start with a fresh sheet of on a fresh graph paper, or if you're screenshotting, go ahead and screenshot it. All right, so we're gonna start off with the very first one. I don't know why I graphed that already. All right, first one is y equals 2. So we just talked about this, -2. Y is always equal to -2 no matter what x is. So x is -5, y is -2. X is -9, y is -2. X is 1, y is -2. Whatever I say x is, y is always equal to 2. X is 6, -2 is y. X is 10, -2 is y. So it's a horizontal line going in this direction. All right, what is the part of that line that I care about? I only care about x values that are between -4 and -1. So x values that are between -4 and -1. Boom. I only care about this piece of the graph. So let's transfer this piece of the graph in here. So -4, -2, -1, -2. So -4, oh wait, oops. -4, -2, and -1, -2. So I only care about this piece. All right, let's talk about these endpoints. Are there any arrows inside this box? No, the arrows are outside the box, okay? So I'm looking at whether they're open or closed. This one has less than or equal to, so this is closed, and then this is also closed. So both of those lines are closed. So I finished the first one. On a fresh sheet of paper, right? Go ahead and graph the second line. So this time, again, I have a y-intercept of -2, so -2. And what is my rise and run? There are no numbers there. So remember, rise, run is going to be 1/1 because it's invisible 1. So I'm going to rise 1, run 1, 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 rise 1, run 1. All right, and if I was to go opposite this way, because you see this line is to go like this, if I go backwards, it's down, left, down, left, down, left, down, left, down, left, down, left, down, left. I probably don't need all those points, but you know, whatever. Again, use a straight edge because it'll be more accurate. All right, so let's go ahead and look at my restrictions. So this is my line, and I only care about x values between -1 and +3. So I only care about this part of the graph. I only care about this part of the graph. So let's transfer just this part of the graph into my answer. So this is going to be -1, -3, and 3, 3, 1. -1, -3, -1, -3, and 3, 1. Boom. All right, so again, looking inside this box, do you see any arrows? No, the arrows are outside the box, so these are not going to be arrows. And then my restriction, let's see what this does. So again, is this open or closed? That's open, so we'll make that one open. All right, and then is this one open or closed? That one is closed, so it's already closed. All right, so that's how you work through these problems. I'm going to do another one just in case you don't get it because you know you are at home and you can't tell me, hey, Miss Ainley, I don't get it. I'm actually going to focus on one that's off the graph this time. So here's another one that's off the graph. So again, on a fresh sheet of paper or take a new screenshot, whatever it looks like for you. All right, so let's go ahead and do this. So let's start with this first equation. So we have 3x. So we have 3x plus, ooh, that's not what I meant to do. 3x plus 14. So my y-intercept is 14. It's off the graph. So anytime, again, I'm off the graph, I make a XY table, right? And I plug in numbers. So instead of just plugging in random numbers, I'm going to go right to my domain and I'm going to pick those numbers. So I'll start off with what my domain is, which is -5. So I'm going to plug in -5. And then I just need one more, two points make a line. So I just need one more number. And I'm just going to make it less than -5. So -5 is here. Anything less than that. So any one of these numbers, I always pick the last one. If it so happens that the last one is off the graph, then I pick a number closer to -5. So I pick -6 and check that. All right, then all you do is plug it in. Anytime you see X, you're going to put in -5. So I have 3, -5, because I see X, plus 14. And you're going to put that in a calculator. So 3 times -5, -15 plus 14, that's +1. And then -10, so I have 3, I see X, put in -10 plus 14. 3 times -10 is -30. -30 plus 14 is 16. Let me just double check that. 30 minus 15 is 15 plus 1. Yep, so 16. And oh my gosh, look at that. There is no 16 on the y-axis, right? That's off the graph. So I just talked about this. I'm not going to use this line anymore because this is off the graph. So I need to pick a number that's closer to -5. So I'm gonna pick, let's pick negative, I don't know, it doesn't matter. Let me pick -8. Hopefully that's on the graph. And if it's not on the graph, I'll come closer. So again, -5, everything less than -5. So this is off the graph. Now I'm trying this one, okay? All right, so once again, it's 3, then I see X, so -8 plus 14. So 3 times -8 is -24 plus 14 is -10. Oh, that just gets me on the graph. That's what I'm talking about. All right, so I got my 2 points. So let's go ahead and graph it. So -5, +1, and -8, -10, -8, -10. All right, so again, straight edge, okay, a ruler, your composition book, debit card, something like that. All right, so this is the line. All right, now let me look at my restriction. So again, my restriction is anything less than X is less than -5. So here, everything to this side. Okay, so all of this. So let's transfer that. So I've got -5, 1, and I've got -8, -10. -5, 1, and then drag it negative, what did I have? What was the other? -8, -10. Boom. All right, so now let me deal with my endpoints now that I've transferred this part of the graph. What does this look like? This is an arrow, so you're going to click it twice. And then this one is less than, just strictly less than. So is it open or closed? It is open. So click that once. And you've graphed that one. All right, let's graph the second one. So again, start on a new graph so it doesn't confuse you. I'm just going to erase all ink. All right, start on a new graph and we'll graph in this second one. But this one is easier because it is on the graph. So it's a little less work to plug in. But again, whatever is easiest for you, you can do. You can still make X and Y for this, but I'm not going to. All right, so my y-intercept is -4. So we're going to go to -4, put a dot. Then what does rise over run say? So here is invisible 1 over 1. So we're going to rise 1, write 1, rise, run, rise, run, rise, run, rise, run, run, rise, run, rise, run, rise, run. Okay, and then bringing this line this way, I'm going to go, so down, left, down, left, down, left, down, left, down, left, down, left, down, left. And of course, if you have a straight edge, you can just use that. For me, I don't. That's why I'm just plotting so many points. But that's what the graph looks like. Now let's take a look at our restrictions. So I'm looking for values bigger than 2. X is greater than 2 right here. Everything on this side, X is greater than 2. Let's transfer the line over. So I've got 2, -2. And then I guess I'll put 9, 5. With an arrow, I can put 10, 6, actually, because it keeps going that way, 10, 6. Let me see if it'll let me do 9, 5 and extend the arrow just so I can know. So this is -2, -2, and then I'll put 9, 6, -2, -2, and then I'll put 9, 6. And I just want to see if I extend this to be an arrow. Oh, it keeps going. That's interesting. Actually, let me see if I can do that too. So let me try 2, -2, and let me do 4, 0. So 2, 2, -2. Wait, is that right? Yeah. 2, -2, and 4, 0. And if I make this a line, it does. Oh, cool. That's nice. So any two lines, really, any 2 points you can pick. And once you extend it, it's going to, extend it for you. So that's pretty cool. All right. So that's the arrow on this side. And then on this side, what do I have? Is it open or closed? So looking right here, it is open. So let's go ahead and open that up. All right. So hopefully this, ooh, why did I get it wrong? Oh, why did I graph this here? -5. So this is, I need to repeat. Let me repeat this graph. So maybe I did that wrong. And unfortunately, I erased. I wonder if there's a way to undo just so I can see which part I got it wrong. Just bear with me for 1 second. Is there undo anywhere? What are these buttons? Window mode, second delay. I think that's share, open file. Okay, there's no undo. All right, I'm just gonna do it again, and I'm not sure what my mistake is, so you can rewind the video and just see what my mistake will be. Oh, here's undo. But I think I did a new snip, didn't I? Let's see. I'm just gonna undo and see what I did on that graph. But obviously, if you make a mistake, and this is good, if you make a mistake, then you should actually look why it's wrong so that you don't get it wrong again. So it looks like, so my graph is here, -5, 1, and their graph is -5, -1. So it's this point right here. So I made an issue with my calculation. So we're gonna do this part again. So we have -5, 3 times -5 is -15. Oh my gosh, y'all. -15 plus 14 is -1. So this was my error. So it's -1. So this should have been -5, -1, -5, -1. And that's the only problem. So this is good. I love when I get questions wrong because it also shows you that, one, I'm human and I make mistakes as well. And that's just what math is. And then two, you need to go find out what did you do wrong so that the next question that you do, you don't get wrong. So for me, what this means is, hey, Miss Ainley, what you might want to do is each time you do this, double check it with a calculator to make sure you're not getting the computational wrong. I hope this helps. So go ahead and knock this out. And then I'll see you in class.